Here we go, 8th graders. We're starting on Module 4, Lesson 1. Our student targets are that you'll be able to write mathematical statements using symbols to represent numbers, and that you will know that written statements can be written as more than one correct mathematical sentence. So there's a couple different ways we can write things. So I want you to take a look at these two things and find out how they're similar. Okay, one is the story sentence and one is the equation. And it says the number 1,157 is the sum of the squares of two consecutive odd integers divided by the difference between the two consecutive odd integers. And then look at that equation, and what do you notice that is similar about them? Okay, so let's take a look at some of those things that we find that are similar. Okay, so I'm going to first find, I notice that this 1,157 is the same thing as right here. 1,157, and that equal sign restates the word is. All right, now let's look at the next thing. We have the sum of something. What does sum mean? Good, we're going to add something. So if you notice, we're adding right here. There's the word sum. We're going to add two things. What are we adding? Well, we're adding the squares of something. We need to know what consecutive means. So here is a squared term, and here appears to be a squared term. And then we have something it's divided by. Divided by is our division line right here. And what is it divided by? It is divided by the difference of something. There's our difference. And it's the difference of two things, the two consecutive odd integers. Now look at how we have this right here. We have there's one and there's one. Look at how they compare to in the numerator. The x plus 2 is the same, but this one is an x squared, and this is an x. Well, both of these were actually squared, so our x is the same also. Which one of these do you find easier to write or to read or to understand? I definitely find it easier looking at symbols versus story problems. I find story problems way more difficult. So we're going to go ahead and we're going to take a look at these. And again, this is not in your textbook, although we will be starting on page 1 in a little bit, but you don't need it right now. It says we want to express the following statements using symbolic language. A whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. That's a whole lot of words. So we want to always start with just defining the variable. So in this case, we're going to say x is the whole number. So we're just going to say whatever this whole number is that we're talking about right here, we're going to call it x. And so we know that x has the property. That just means that what you're doing to it is going to work, okay? So it says, using x to represent the whole number, write the square of half the number. So I want you to try to write at least one, if not more than one, different way to write the square of half the number. The square of half the number. Well, if x is the number, how do you write half that number? Definitely a couple different ways, right? So we can have half of x. That would be one way. We could put this x in the numerator and write it this way, half of x. But we also need to look at that it's the square of that. So what does squaring it mean? Yeah, we have to have that exponent of 2. So we would have to take this and square it, or take this and square it, or we could actually do that squaring and getting something different. For example, we have x over 2 squared. We have our 1/2 x squared. But if we distributed that squared symbol to one of these, we could say x squared, and 1/2 squared is 4, 1/4. See how it's down there on the denominator? Or we could actually just write it. If we looked at this problem up here, if we did that, we would have our 1 on the top. Sorry, it's the first one up top. We would square a half and we would get a 4th, and we would square the x and get x squared. So all 4 of those are the same thing written different ways. So if you did it one way and your friend did it another, that's perfectly fine. They're both correct. Now they want us to write the entire statement. So we have already done, let's see, if I look at this, we have already done this whole part right here. All right, a number has the property that when the square of half the number, we've got a square of half the number, we need to do something with that now. So what can we do? Well, we need to subtract it from 5 times the number. Well, the number is x. How do we write 5 times that number? We would write it 5 times x, because whatever x is, 5 times it multiplied. But we know that it is subtracted from, this first part that we wrote is subtracted from 5 times a number. Which one has to go first? Good, the 5x. We have to have that before we can take something away from it. Here we go. I wrote it 5x minus x over 2 squared equals the number itself. So I wrote equals x. Notice there's a lot of stuff that you're going to have to distinguish between. Pay very close attention, because even if you just wrote this x over 2 squared in front of the 5x, the whole problem would be incorrect. All right, let's take another look. Express this following statement using symbolic language. Paulo has a certain amount of money. If he spends $6, then he has 1/4 of his original amount. So let's kind of look at what we know, okay? First thing we need to do is we need to come up with our variable. Well, Paulo has a certain amount of money. Do we know how much he has? No. So we're going to put that as our x, and that is the money Paulo has. Okay, and now we need to do something with it. If he spends $6, how do we represent spending money? Yeah, we're going to add, right? So we know we're going to have to add 6. I am incorrect. We are subtracting 6. Spending is going down. Don't know what I was thinking. Spending 6 goes down 6. And then the last thing is, how do we write 1/4 of the original amount? Well, what was the original amount? We already said what that was. Right, I know we don't know what it is, the exact amount, but we know it was x. So if I have 1/4 of x, now we need to put all of this together. Ready? Paulo has a certain amount of money. He spends 6. So I put those two together. Then he has, then is the equal sign. It equals 1/4 of the original amount. All right, let's take a look at the next one. Express the following using symbolic language. The sum of 3 consecutive integers. Big question. What is consecutive? Oh, I'm so glad you remember that. Consecutive means in order. Okay? In order. So, could be 1, 2, 3. Could be evens, 2, 4, 6. Could be odds, 1, 3, 5. Consecutive means whatever you're counting by, it is in order. So if you're counting by 5s, 5, 10, 15, those are all consecutive. It just depends on what you're asking for. So we have another word, big clue. We have a sum. That means we're going to do what? We're going to add. Good. And when we add these 3 numbers up, it's going to equal 372. So let's go ahead and we need to find our numbers. What would our first number be? Do we know it? Absolutely not, right? So we're just going to call it that, x. And we're going to say that's our first number. Now, we know that there are 3 consecutive integers. Do we care? Are they odds? Are they evens? Yeah, they didn't say, right? So we know these are out. It is literally going to be something in a row. In a row. Now, it's obviously not going to be 1, 2, and 3, or 1 plus 2 is 3, and 3 plus 3 is 6. That's definitely not 372. So as we go to our second number, how did I normally get from 1 to 2? I added 1, right? Well, how do I get from 1 to 3? I had to add 2. So when I look at my second number here, which would have been the number 2, I would have had to say x plus 1 gives me my second number. And then the next one, x plus 2, would have given me my third number. Now, if we had a fourth number, what would be next? X plus 3, and so on, because we're all comparing it to that very first number we started with. And the last thing what we need to know is it's going to equal 372. That's our total. All right, let's go. The sum of these, so we're going to add them. There's our first number plus our second number plus our third number. And all of that, when we add it up, is 372. Now we can go ahead and solve. Now in this, let's put all of our x's together. 1x plus 1 more x plus 1 more x is 3 x's. Put our numbers together. 1 and a 2. So we're going to have plus 3 equals 372. And now that's all we would have to do because it just wanted us to express it in this. If we actually wanted to solve, we could go ahead and continue and do minus 3 from both sides. And we would get 3x. Our 3's cancel. We have 369. And then what's happening between our 3 and our x? Good, it's being multiplied, so we're going to divide both sides by 3. X equals 3 went into 3 once, 3 goes into 6 twice, 3 goes into 9 3 times. So our first number, if we were going to solve, would be 123. So then if we wanted to know what our second number is, it's whatever the first one was plus 1 more. So it's 124. And then this one is 100. It's the 123 plus 2, which is 125. So if we needed to know our numbers, these would be our 3 consecutive numbers. All it really asked us for was this. Okay? All right, let's take a look, page 1 in your book. As we take a look, we're going to start with the sum of 4 consecutive even integers. So first thing we need to know is sum. We need to know 4 consecutive even. That's a huge thing. And then we know our answer. Okay, so the first thing we need to do is we know we're going to add stuff and even integers. If I was going to just pick numbers, 2, 4, 6, 8, those are all even. How do you get, if this is my first number, how do I get from 2 to 4? I added 2, right? How do I get from 2 to 6? I added 4. How do I get from 2 to 8? I added 6. So if you notice, when I am going even or odd, I'm adding 2 at a time because we have to skip that number in between. So when I go to write my variables, let's start with first. X is our first number, but x plus 2 is our second number. X plus 4 is our third number. And x plus 6 is our fourth. I should have written smaller. So let's put it all together. We know we're adding. So we're going to have x, that's our first number, plus our second number, plus our third number, plus our fourth number. All of that equals negative 28. Now, if we wanted, we could leave this just how it is, and that would be perfectly fine. If you were going to solve, you would put all the x's together, all these numbers together, move the numbers to the other side, and go ahead and solve. Let's look at number 2. A number is 4 times larger than the square of half the number. What does the word is mean? Equal, good. So a number, let's start. Do we know the number? No. So x is the number. Okay, how do you write 4 times larger? Awesome, 4 times larger than the square of half the number. Well, how did we learn to write that? Half the number, I better get rid of that because that's not really what we wanted. Half the number, half of the number, there's half of the number, but we need to square it. So we need to take that and square it. And this right here is 4 times more than doing this stuff right here. So here we go. There's our number is, and it's 4 times larger, 4 times whatever we just got. And we just said it was half of x squared. So we're going to have to square this, multiply it by 4, and that's what our number is. It's a lot more difficult than we've been doing, right? All right, let's look at number 3. Stephen has some money. He spends $9. He will have 3/5 of the amount he started with. Okay? Then means equal. Ready? Do we know how much money he has? Nope. How do we write spends 9? Minus 9, good, spends. And then he will have 3/5 of the amount. How do I write the amount he started with? It's right there. So we can write that as 3/5 of that. Okay, so that's his result. All right, we can put all that together. He has some money. He spends 9. Then he ends up with 3/5 of what he started with. All right, you guys are going to try number 4 and 5. And when you're done, go ahead and hit the space bar and start the video back up and check your answers. There we go. On number 4, we have x squared plus 2x minus 3 equals 129. And number 5, 1/3 x minus 5 plus 171 equals x. Go ahead and head back to the classroom.